In this tutorial, we are going to look at solving exponential equations, where before we had to go into the calculator and go into the table and maybe have a whole number as an answer for years, and we didn't know exactly when it crossed over into the amount that we wanted. Now we can actually solve the exponents and get decimal exponents so that we know exactly when something occurred instead of just by the year or by the whole hour or that sort of thing. So if we look at an exponential equation, is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, we have a couple steps that we're going to try. So try writing them so that the bases are the same. So we're going to look at if the bases are the same, then the exponents must be equal, given that b is not equal to 1 or 0. And then if we take a look at that, so if b to the x equals b to the y, there's no way for them to be equal if the bases are the same and the exponents are different. So if I have 2 to the x equals 2 to the y, then the x and the y have to be equal, right? So what if I had 2 to the 4th and 2 to the y? To be equal, this exponent would have to be 4, because it would have to be 2 to the 4th equals 2 to the 4th. We can also look at taking logarithms of both sides. So we know that an exponent and a logarithm are inverses, just like if I were to add or subtract square root and square. Whatever I do to one side of the equation, I do to the other side. So in the same way, if we know values a and b are equal, then the log of a must be equal to the log of b, because their exponents have to be equal. Logs are exponents, so they have to be equal. Given that a is greater than 0 and b is greater than 0, so we're not going to do it if it's an exponent of 0. So we know that if we have a equals b, then the log of a, log base a, has to be equal to the log of b. So, but these are both log base 10, right, at this point? But can't we take the log with any base to make sure that we have what we need? Let's look at number 1. So move this up just a little bit. Number 1 is 81 to the 3x and 243. So I'm going to look at that and say, 81 and 243 are not the same base, but I do know that I can divide 81 by 3. So then I would figure out, okay, what is the exponent for 3 that makes 81, and what is the exponent for 3 that makes 243? So we have 3 to the 4th power is 81, and that's raised to the 3x. And then 3 to the 5th power is 243. So now, let's simplify the exponents, power to power. So 4 times 3 is 12x. And we have 3 to the 5th. Now the bases are the same, 3 and 3. So that means that 12x equals 5. The exponents must be equal. So let's solve. So the exponent has to be 5, or the x value has to be 5/12. We are going to make a change to number 2, so go ahead and cross that off, and we're going to write 64 to the 0.5x equals 16 to the 0.75. So go ahead, pause the video, and solve that new equation. Okay, so we can look at 64 and 16 aren't the same base. 64 goes to the 16. 16 times 4, those aren't the same number, so let's change it to a base of 4. So 4 to the third is 64, and raise that to the 0.5x. And 16 is 4 squared to the 0.75. And then we have this side is 4 to the 3 times 0.5. 3 times half is 1.5x. And then we have 4 to the 2 times 0.75, which is really 1.5. And then we know the bases are equal, so let's put the exponents equal to each other. And if I have 1.5x equals 1.5x, or 1.5, I divide by 1.5, and x equals 1. Go ahead and try number 3 at home for homework. Let's take a look at number 4. So 49 and 343 are not the same number. I know that 7 squared makes 49, and that's raised to the negative 2x. And then 49 times 7 is 343. So we have 7 cubed on the right-hand side. And I'm going to simplify that. 7, 2 times negative 2 is negative 4x. And then we have 7 cubed. So this is a negative 4x. The bases are the same, so negative 4x equals 3. Exponent set to get equal. Divide by negative 4, and I get x equals negative 3/4. Go ahead, pause the video, try number 5. On number 5, we have 25 and 125, not the same, but they both have a base of 5. So 5 squared makes 25, and that's 3x to the 3x plus 3 equals, and 5 cubed makes 125, and that is 4x minus 5. And then we end up with 5 to the 2 times 3x plus 3 equals 5 to the 3 times 4x minus 5. Bases are the same, so we set the exponents. 3x plus 3 equals 3 times 4x minus 5. And then we just solve. So 2 times 3, so we have 6x plus 6 equals 12x minus 15. And then I'm going to subtract 6x. And I get 6 equals 12 minus 6 is 6x minus 15. And then I'm going to add 15 to both sides, so we get 21 equals 6x. We divide by 6 on both sides, and we get x equals 21 over 6, but we can divide the top and bottom by 3, so 21 divided by 3 is 7. 6 divided by 3 is 2. So our answer is 7/2. Go ahead and do number 6 for homework. Let's look at the next example. And we have 3 to the negative 2x equals 10. And 3 and 10 don't really have the same base, so I can't really do anything with that as far as exponents. But what I can do is I can take a log base 3 of this side and a log base 3 of the other side. So I end up with a log base 3 of 3 to the negative 2x equals a log base 3 of 10. So I'm taking the log of both sides because it's the inverse of an exponent. And we know that log base 3 of 3 is 1. And then we bring down the negative 2x. So we have negative 2x equals log base 3 of 10. And then we divide both sides by negative 2. And x is going to be equal to log base 3 of 10 over negative 2. So we can just put that in the calculator. But I will write that for us. And then you can plug it in the calculator and see what you get. And we get negative 1.05. Go ahead and pause the video and work on number 8. So 2.5 and 13.5, I'm not really going to find an exponent for them to be the same. So I'm going to take the log base 2.5 of the left and the log base 2.5 of the right. And I know if I take the log base 2.5 of 2.5, that's 1. So I end up with 4x plus 1 on the left. And then on the right, they don't cancel out log base 2.5. of 13.5 is just that. We're going to have to calculate that later. So then we're going to subtract 1, and we get 4x equals log base 2.5 of 13.5 minus 1, and then divide by 4, divide by 4. So x is going to be equal to the log with a base of 2.5 of 13.5, so that's one thing, minus 1 all divided by 4. So we put that in the calculator, and let's see what we get. And that would give us 0.46. Go ahead and try number 9 at home for homework.